My name is Jessica, and today we are going to be talking about deserts and winds. The first thing that we're going to be talking about is what is a desert. A desert is an area that is characterized as a desert because it has minimal or low rainfall, regardless of what most people assume, which is that deserts are characterized as deserts because of how hot they are. Deserts are usually found in polar regions between 30 and 50 latitude. The next thing we're going to be talking about is aeolian processes, which is just one way that deserts are formed. As you can see in this picture here, it's how the wind is flowing in order to create the desert. The next thing that we're going to be talking about is a rain shadow. So a rain shadow is when a mountain range right here, as you can see in this picture, blocks an area from receiving rain or water or anything like that, creating a rain shadow. And this is why this area on the side with the red arrows is going to be turning into a desert right here because it's not receiving any of the water from this area over here. The next thing that we're going to be talking about is westerlies versus trade winds. So basically, trade winds are a lot closer to the equator than westerlies are, and trade winds are closer to the Earth's surface. Trade winds also blow east to west, but westerlies only blow from the west. So as you can see right here, your trade winds are going to be the ones in the middle, and your westerlies are going to be closer to the top and the bottom. And the last thing we're going to be talking about is the Hadley cell. The Hadley cell is when air is leaving from this area of the equator right here. You can see it leaving. And that is going to be creating arid areas for deserts to be in because it's going to be dry.
Hi, my name is Kristy Papayuano. Today's date is 4/27/21, and this is Geology 1040. Today, I wanted to give you a little information on some things that occur in the desert. First, I wanted to talk about dunes. Dunes typically form from sand piling up around an item, such as a plant. It grows as more sand is piled on by the wind. You can usually tell which direction of the wind by the shape of the dune. The pieces of sand travel up one side that is sloping by siltation, and then it drops off the cliff on the other side. Eventually, that causes the sand dune to move forward. There are several different types of dunes. The first is barkens. They kind of look like a horseshoe. The second are blowout dunes, and they kind of look like the reverse of a barken. Next is the transverse dunes, and they look like they're in lines or in rows. And then the linear dunes or longitudinal dunes, which look like the different ones kind of combined. You can actually find dunes on other planets as well. Next, I would like to talk about desert pavement. It happens when wind blows away all the fine loose material, and then it'll rain, and some things get compacted down, and then some other material floats up to the top. Over time, it thickens into a pavement-like material.
Hi, I'm Michelle Dees. I will be presenting the aluminal fans and Bahada. I'm going to share my screen. Okay, so what we're looking at right now is the Cottonwood Mountains and Death Valley in the Death Valley National Park, California. So what we're essentially looking at right here is at the bottom kind of the mountain where you see the lines coming down, those are the aluminal fans. And then the farther you go down is the Bahada. So we're going to talk about that right now and kind of what you see, fine grain materials, gravel, sand, and some boulders. So the aluminal fans, they're fan-shaped deposits that form from the deposition of sediment within a stream that runs onto the flat land at the base of the mountain. So you can see kind of how where it's ran down the side of the mountain and kind of looks like roots to a tree at the bottom. And this is the aluminal fan in bad water at Death Valley. So it's a part of the first picture that we saw. So part of what comes out of these fans are granite boulders, gravel, sand, silt, sediments of all different kinds that flow through them. During high flow of heavy water, the rainwater is very rapid. So the bigger the particles usually start falling out first as the other particles keeps going. And then at the bottom you have the slit, the silt, sorry. um, but this is also Death Valley National Park, and you can see those boulders are quite large. Looking at the pictures, you wouldn't think a boulder that large would be coming out. So this is just another picture of part of the big mountain range in Death Valley that we were looking at. You can see those lines at the very bottom is the fans of where rainwater has rushed down and kind of moved through the mountain, forming these lines on the ground. So the Bajada, like I said before, is the slope at the base of the mountain. You can kind of see in the picture where it's sloped down a lot and all the fans have came down to join together. That's kind of where you're looking at for the Bajada. In this picture, it's the west side of the Snake Range in Nevada, which is different than the other pictures, but I figured this was a great way to look at it to see the alluvial fans and how they come together for the Bajada. So these are formed from eroded sand and gravel when water pours down the canyon streams onto the flat playa and the alluvial fans run into each other. I think this is a great picture to be able to see all the different parts of what we're looking at. So this is again, it kind of looks like the other picture, little of the alluvial fans, but this is the Bajada on the west side of Death Valley. So this is going back to the first picture that we looked at. You can kind of see where they've all came together, and at the very bottom where it just looks like sand is kind of where the Bajada is, where all the materials have came out. So like I said, this is a great way to just see all the different parts. And that is it. I hope you enjoyed. Thanks so much.
Hi, this is Chandler. I'm going to talk about the humidity and climate in different deserts. So, deserts can differ in temperature, being hot or cold, but they are almost always arid, not humid, and this is because the dry air. Water normally can't reach the surface without evaporating during precipitation, and it's so hot and arid that there isn't enough water vapor to form clouds in some cases. Some examples of the hot and cold deserts are the Gobi Desert in China and the Arctic Desert in parts of Russia, North America, and Norway, as you can see in the map. Some examples of hot deserts are the Sahara in Africa and the Atacama in South America, which I'm going to talk about a little bit more. The Atacama Desert in Peru is the driest desert on Earth and is in a rain shadow. Um, as you can see from the example, the right side of the picture is where the Atacama is, the rain shadow, and the left side is going to be more near the coast. And the cold upwelling water current prevents water from evaporating and being transported to the Atacama Desert. It also has interesting special microbes that can withstand the extreme dryness and temperature. And because there was a unusual rain in 2017, people thought that there would be just beautiful blooms of flowers, as that happens in some deserts after unexpected rainfall. But instead, the water killed off a bunch of microbes. They were extremophiles, adapted to the extremely dry environment, and when that changed quickly, they couldn't adapt, so the flowers died off quickly.